This video will show you how to identify peaks and perform atomic concentration. Step 1 is you need to smooth and differentiate, or use the new combination diff smooth feature, which will automatically differentiate and smooth. Then you're going to select the marker icon, which could also be selected here under Edit Mark Track, or simply this little marker icon. Now as we move our cursor, it shows us down here the EV and counts. So let's pick the largest peak first here. You mark the peaks at the bottom of the peak, not the top. So when I select that and hit the left mouse button, the element marker will pop up, and it suggests it's just going to pick the closest thing. And 920 copper, I'll say yes, that's correct. So notice what it did then is it marked all of the peaks. All the copper peaks are marked. Now select this peak, should be oxygen. Now remember, it's only going to give you the closest pick, so you have to kind of know a little bit what this is. We know that's oxygen, so I'll select oxygen. You know that's carbon. This is sulfur. We know that because copper acts as a getter for sulfur. This is the 105 copper peak here. And then this is silicon. That's probably correct. We did some sputtering on a silicon sample for this test previously, and we may have deposited a small amount of silicon. Once we have all the peaks of interest identified, we can hit the atomic concentration icon, and that will give us a table that shows all of the elements and their atomic concentration percentages sorted by percentage. So this is pretty useful. You can refer to your Auger handbook for more specific information about peak locations and peak shapes. Another thing about markers is that you can do Edit Markers. You can select which peaks are used to do the atomic concentration calculation. So in this case, all these 4 copper peaks have been identified, but we only use the largest peak for the quantification. You could use a different peak if you wanted to, but in general you're going to use the largest peak for quantification because it has the largest peak, gives you more accurate data. You can save marker lists. So you could save this list. If you have a lot of samples that you're running the same thing over and over and over, you don't have to take the time to pick each element like I just did now. Instead, you do that once, save it, and then you can simply load the marker list and then run the atomic concentration after the data has been smooth and differentiated. So that is how you can use the markers to help identify the peaks and also quantify the atomic concentration.